All good? All right, perfect. Okay, so thank you everyone for coming to this talk. I hope you'll find it interesting. Before I kick off the session, I wanted to ask you something. So this is meant to be an interactive session. So there are 5 questions in 5 slides throughout the talk. I hope that you'll be able to, some very easy questions for you in the crowd. Please shout the answer just to help me out, because if you don't, it's going to be really awkward. So please just shout out the answer, okay? The other thing, this will be an intermediate advanced level talk, not in depth, but definitely in breadth. We're going to cover a lot of different topics, a lot of different ground. If there's any questions or anything, you can reach out at the end of the session. Is the mic good? The audio, sound quality, all good? Perfect, thank you. So, who am I? My name is Federico. I work at Contino in London in the UK. Contino is a global DevOps and cloud transformation company. We help large regulated enterprises moving from on-premises to cloud, building architectures in cloud, and helping them changing the way in which they deliver digital products. This is my background, this technology, architecture, engineering management as well. So, we're talking about Kubernetes today. We have to talk about Kubernetes today because when I talk to a lot of our customers, a lot of our clients in the UK, in Europe, there's a common trend. There's a theme there. Everybody says we're adopting Kubernetes because it gives us something. And we're adopting Kubernetes in a variety of ways. Sometimes on-premises, sometimes in cloud. Kubernetes has a very relatively recent history. Containers have been around for a while, but Kube is from 2015, pretty much 2014 as well. And the managed service providers, that are offering Kubernetes services, AWS, Azure, GCP, IBM, all of them, have started offering Kubernetes as a managed service in 2016, 2017. So we have this technology that has been there for 6 years now, has been there for a while. And we have a more mature ecosystem as well. The number one reason, though, for which companies are adopting Kubernetes, when I speak with them, are like, we're using Kube because it gives us a number of things. Number one thing, because it's portable, because it makes our application portable across different cloud providers. We're using Kube because it makes things standardized for us. And this is there in literature. It is there in blog posts as well. Everybody talks about this. So today, we're going to see whether it's true or not. We're going to follow the journey of a demo application. Who are we in this crowd? We are a migration team. We have been engaged by a B2C startup company offering a mobile application to their customers. We're running a backend on AWS, and they told us, you have to move us to GCP. In fact, you have to move us from EKS, the managed Kubernetes service on AWS, into GKE. Okay? This is the job. The job we're going to do today is to migrate this application from one to the other side. And there are some good news. So, number one, the landing zone on GCP has already been built. The landing zone is there. Our presence in GCP has been built. We have GKE, so the managed Kubernetes on GCP up and running. It is running. We can stop the world, which is a great thing. So we don't need to do any clever traffic shifting policies. We don't have to do anything special about this application. The application runs on a modern tech stack, and we are going to turn off AWS, virtually turn it off, and we're going to turn it on GKE. We're going to tell our users, move, new endpoint, go to GKE, have fun there. What I wanted to take away is that this is an easy migration. This is a very easy migration that we're going to do, easy technical migration. We have a number of stakeholders, though. Don't get fooled. As in any migration, some of our stakeholders are our users that clearly want to use the app and continue using the app in GKE. But we also have backend developers that need to be able to continue their deployments both in AWS and GCP. We have a security team that needs to make sure that if we were secure on AWS, we need to be secure on GCP as well. And we have an SRE DevOps infra team, us, pretty much, that need to be able to continue deploying things from one place to the other. So what is the AWS architecture? Now, I assume familiarity with AWS in the crowd here. Super easy, as I said, super simple. We have a mobile application. The mobile application calls one microservice deployed inside a Kubernetes cluster. Is a HTTP REST microservice, super simple. Microservice gets an image from our hypothetical mobile application, uploads the image on S3. The second microservice is notified by an SNS queue that an image has been posted, has been uploaded there on S3. There's some processing of the image, and then a third microservice reads some secrets involved and sends a message, an email to notification to our users. So simple architecture, 3 microservices in Golang, 3 containers, super easy. 2 managed services, S3 on one side, SNS, and also, I forget, an RDS database that we're using to store our metadata. Pretty straightforward, nothing magical here. A few monitoring tools as well, before I forget those as well. So we have Prometheus and Grafana that are monitoring tools there. How does it look like in GCP? Very similar. In GCP, we're running on GKE, Google Kubernetes Engine. We're running Cloud SQL. We don't have SNS, so we have to use PubSub on GCP. And then we have cloud storage. The external tool we're using there to send email notifications to our users, that SaaS provider is still there. So super simple migration. Okay. We have a migration journey we have to follow because we have been using Kubernetes for a while and we have been told something. We have been told this is portable. So my premise here is that I want this to be a turnkey migration. What I want to happen is that I'm going to change my CI/CD pipelines, GitHub Actions, Jenkins, whatever it is, and I'm going to migrate everything to Kubernetes Engine. Super simple. We've been told this. Okay. So first question here. Please shout the answer. What happens if I go on my CI/CD pipelines, I just change the CI/CD pipeline, and I say, don't deploy on EKS, on AWS, go and deploy on GKE, Google Kubernetes Engine. Will it work? Will it not work? No. Why? The image, exactly. So point number 1, straightforward. The image doesn't work there because the image is on ECR. Okay, so you have 3 options. Option number one, I can keep the container registry in ECR and pull from GKE images, from the nodes in Kubernetes Engine. Can I do that? Yes, I technically can. There is a GitHub project online that helps you doing this, but that means that I have to use managed nodes on GKE, so I cannot rely on autopilot and having GKE managing the nodes for me. I don't want to do that. Option 2, I can move to Google Container Registry, not a problem. Option 3, I can embed a container registry within Kubernetes, and I can use the CNCF tool. Yes, I can do that. I have 3 options. Option 3 means I have to manage things. That is a bit painful. So, straightforward, I'm going to change the container registry. I'm going to pull from ECR, push to Google Container Registry, have Kubernetes, change the YAML, change the endpoint. Super simple, no issues. What about security? Because we're in the real world here. Yes, I can change that. I can change the images. But now my InfoSec team comes to me and says, listen, we have to follow a compliance standard. Our compliance standard, the most common one, CIS benchmark for compliance, we have to make sure that our cloud environment is secure. The CIS benchmark for GKE says you have to use binary authorization. So you have to deploy signed images using a feature that is in GCP called binary authorization if you want to deploy and stay within compliance, stay in compliance. That feature does not exist on AWS. Yes, I can implement the feature, but it's not a requirement on AWS. And if I have to implement the feature, I have to do it with CNCF tool. So the first thing that we notice here is the fact that if we want to stay in compliance, then I have to add something to my deployment, which can make it way more complex because now I have to sign the container images that I'm using on the cluster. We're lucky. Our security team is like, no problem, no problem. We don't want you to do this. It's too complex. We're good. Okay, perfect. So our migration journey, step 1, change container registry. So I go back to my CI/CD pipeline. Will it work now? Will it work now? Can I deploy my application? Will my application work? No, why not? Database, exactly. So I have to change database host. What do? I move from RDS on S3 to, from RDS on AWS to Cloud SQL. Good news here, I'm running Postgres on RDS. They are very much similar. The two services are absolutely similar. This wasn't true in 2019. Cloud SQL did not offer the same set of services or features that AWS offers. So they're very similar. Doesn't change security posture. Very easy. In an ideal world, I wouldn't want to do this though. In an ideal world, I don't want to rely on an external service. So what could I do? I could deploy Postgres within the cluster using something like a Postgres operator and have Postgres inside my cluster, such as when I deploy then on GKE, I have Postgres already in the cluster. If I do this, if I deploy GKE inside the cluster rather than using database as a service, I can totally do it. I can do it at scale as well, as Zalando shows in the Postgres operator on Kubernetes with something like called Zalando Patroni, which is manage HA for Postgres in Kube. I can do it, but I have to maintain it. I have to do maintenance of it. And this is the same thing across the stack. This maintenance, this is the crux of the issue, the core of the presentation, which is what should we do when we design the services? There's a complex trade-off here. On one hand, if I want to be more portable, I have to import things inside the cluster. If I do it, I have to pay a price. I have to pay maintenance price for all of this. Okay? There's a significant cost attached to it. If I instead hand over things to cloud provider managed services, I get some benefits. My service cost goes down because I don't have to maintain that. And my total cost of ownership changes. Cloud providers would manage it for us. This is the trend across the presentation. Kubernetes itself is not feature complete. I need to use managed services to complete the deployment of an application, and so I have to rely on this. The trick here is that I don't want you to get fooled. The decision of importing a service in the cluster or relying on a managed service is a business issue, is not a technical decision. I don't choose Postgres operator or I choose RDS based on their technical features. No, I choose based on how much it is going to cost the company to operate one or the other. This is a business decision. This is a decision that IT, if you have IT separate from the business, doesn't make. You have to make it with the business because there's a clear implication in cost and velocity. It's a trade-off you have to make there. Okay, so far easy, so far so good. We changed a container registry. We changed database engine. So now we're good. Our applications are up and running. They're up. All 3 applications are up and running. So we go to our users and we say, hey user, why don't you try calling an API endpoint? Why don't you try to upload an image? The user tries and gets, ouch, 500. Why the user gets a 500? From the architecture there. Not there yet, not a pub sub yet, but another managed service right on top. Exactly, our magical storage service. So we were relying on S3, we're not relying on S3 anymore. What can we do? Well, number one, I can keep the object storage in S3, but I need to give authentication credentials to my application in GCP to go to S3. I can do that, but not super easy. I can move my object storage to GCS, to Google Container Storage. If I can do that, and GCS is very clever, because GCS offers something called S3 compatibility mode for GCS. So Google Container Storage can offer an S3 compatible API layer for which you can call GCS as if it was S3. That is an option. Or option 3, if I want extreme portability and solving this, I can use some of the more advanced, some of the CNCF tools that can help me. So I have Rook, an operator that allows to spin up a Ceph cluster, but I still have to maintain it. Or I think more interesting, this is a CNCF project called KubeFS, or Kube File System. This is a distributed file system designed to natively support large-scale container platforms. With KubeFS in my cluster, I can have an S3-like service inside the cluster. So this is possible, but KubeFS is not a game. So KubeFS is made of multiple systems, metadata subsystem, data subsystem, resource manager. So I can have KubeFS inside the cluster, but I have to maintain it, I have to pay a price. There's a fourth option. It is called Container Storage Interface. This is or CSI, is a standard for exposing blocks and storage systems within Kubernetes. This is part of Kubernetes GA. So for all of you, when you're mounting volume within Kubernetes, you're mounting a persistent volume on AWS, you're mounting an EBS volume on Kubernetes, you are already making use of the container storage interface there. The feature has been GA for a while, so what we do, we can attach volume to our pods. This is a EBS volume. When we're calling S3, though, we're not doing this from our pods. Our microservice is connected to S3 with an HTTP call. So if I use container storage interface, Kubernetes tells me, listen, you can mount your storage as if it was a directory inside the application. At that point, if I do this, if I mount S3 as a directory inside the application with a fuse file system, a fuse mount, I can then swap S3 for Google Container Storage. The application will still see a directory, continue seeing a directory, and that will make it portable because it's just a folder. This is an option that I've explored a bit, but I have to say I don't think it works, or I don't think it works as we want it to work. This is described as well in those drivers. The game is always the same. When you're mounting a file system that is not POSIX compliant, and you have to make it POSIX compliant, then trade-offs need to be made. For example, the standard Google Kubernetes bucket storage on CSI is not, by definition, by description as well on GitHub, is not compatible with symlink, hard links, doesn't support renames, doesn't support fsync, the system call either, so it flashes on close. There's a number of trade-offs you're making there. Kubernetes will tell you. Kubernetes storage interfaces can help you with portability. I don't think that they are ready yet there. Maybe they will in the future. There's a number of CNCF projects as well that try to do this. So, assuming that the standard way of doing it is actually not there yet, we have to just make our things. So what do? We move to GCS. We move to GCS, Google Container Storage. It's very simple. Google Container Storage, I have to do a change though. What is the change that I have to do? I have to change SDK. If my application in Golang doesn't talk to S3 anymore, but talks to Google Container Storage, I have to change the SDK, I have to change the libraries. In changing the SDK, changing a library in an application, is a less trivial activity. Most applications will have a layered approach, so you're changing the storage layer of the application. We can do this. But what if we have more than one microservice? What if we have 3 microservices? What if we have 50 microservices there? That's a problem, because I have to change 50 libraries. So how do I do this? What we could do is that we could create an anti-corruption layer. This is a standard pattern in distributed systems, a facade or an adapter that helps us, a microservice, that helps us separating different subsystems that talk on different semantics, that use different semantics when they speak. The application domain and the storage domain are using different semantics. If I implement something in between, I can then have multiple microservices talking to that something in between before reaching the other storage domain, and then I can change it behind the scenes. So what I could do when I create my applications or when I'm changing my applications, I could use this anti-corruption layer. This is the actual term, anti-corruption layer. This layer can really help migrating my applications. Okay, so we change container registry, we change database system, we change storage system. Finally, will it work now? Will it work, or it still doesn't work? Exactly, it doesn't work. PubSub. PubSub is the problem, because I was using SNS, and really just swapping the queue endpoint doesn't work. Even if, in our case, I wonder, why doesn't it work? Because we make a cursory usage of a queuing system. Our microservices are sending a message from one place to the other. This is 2023. We've had this for a number of years, a queuing system. So we'll see what we can do. As we said, 3 options in this case as well. I could use a CNCF project inside the cluster to manage my queue inside the cluster, Kafka, Nets. I could keep messaging in AWS, or I could move to GCP. Here, I want to bring your attention to one thing. The 2 core reasons why we want to keep messaging in AWS, why we want to move messaging to GCP and not keep it in AWS, is because 1, I have an application on GKE, I have queuing system on AWS, I have data egress cost across cloud providers. They will charge me for moving messages one place to the other. That's one cost, that is true. Second reason is latency. If I have application on GKE and SNS on AWS, the normal wisdom will tell you, well, there's a latency cost because you're crossing cloud provider boundaries. Turns out, here is a secret, it's available online as well. When you're moving data or packets from AWS to GCP from one cloud provider to the other, you're not crossing the internet. You're thinking you are, because this is what the expectation is for most of us in networking, but it's not the case, because cloud providers have a very strong link, and this is proven by a report, a company called Thousand Eyes, and the link to the report is there. Traffic flow in between major cloud providers is handed off directly inside the cloud providers, and you don't have to cross the internet when you do it. So there's no latency cost, or there's a negligible latency cost in using service across cloud providers, which is an interesting discovery that I've made when studying this. Cost, it is a true problem though. In our case, what we want to do is to change messaging queue system. We want to move to Google PubSub. Now, this is another problem. I have to change the SDK of the application once again. This is a bigger problem though, because in my experience, and I'm sure that all of you that have built microservices, that have built applications, will tell me, when I changed storage before, when I changed S3 before, that was not a big problem because S3 was just a foundation and it's just usually outside. Now I have to change SNS. Queuing messaging percolates through different layers of the application. The application logic is way more tied with a queuing system, with a messaging system, because there are too many concerns. Changing this SDK is a problem. What could we do? We rely on a more interesting new CNC, well, relatively new CNCF project. It is called Dapr, D-A-P-R. Dapr is a portable event runtime that makes easy for developers to build resilient, stateless applications on the cloud. It's a project that was started in 2019 and is backed by Microsoft. Dapr is really clever and can really help. How does it help? So, before Dapr, our application would connect over HTTP to SNS, PubSub, and just send a message to PubSub. With Dapr, you're running a sidecar container pattern within the pod, and then the application calls on an HTTP endpoint Dapr, and Dapr goes then to PubSub or goes to SNS. So you're talking to Dapr, you're not talking to the app anymore. Exactly how it works, visualized here. We have microservice number 1 talking to SNS, talking to microservice number 2 listening to SNS. With Dapr, both the applications are now talking to their sidecar containers Dapr, and Dapr talks to SNS, or I change Dapr and I tell Dapr, don't talk to SNS, talk to PubSub. And then when I migrate, I don't need to change the application code anymore. I just need to change the configuration of Dapr, making it more concrete. The application is now running, calling HTTP endpoint and saying, send a message there. The HTTP endpoint is provided by Dapr on a sidecar container, and Dapr itself uses YAML configuration. And Dapr, I tell Dapr, go to AWS. So now, to change and move the application across, I don't touch the source code. I touch the configuration of Dapr, and I tell Dapr, hey, by the way, go to PubSub. This is really good because I shift a building block from the application to the configuration. It's a positive thing. It simplifies and increases much more my portability. Most developers here will tell me, I don't really want to make an HTTP call to each one, a custom HTTP call. What I want to do is to use an SDK. Dapr itself provides an SDK with methods. The SDK, I have a different slide here to highlight the fact that the SDK is Dapr SDK. It's not a cloud-dependent SDK. So Dapr, what does Dapr do? Dapr is very interesting, provides a set of building blocks for swappable things. Because what I was telling you before, we've had queuing systems for a million years now. We're making a cursory usage of a queuing system here. We're not doing anything very clever. There's no DL queue management. There's no like fan out. There's nothing special. This is one microservice talking to the other. A super simple config. So Dapr steps in and says, happy times, I can give you that capability. I can give you that building block. Dapr itself supports a variety of building blocks, from publish and subscribe to state management to service configuration powered by MTLS, very similar to Istio and other service meshes, to a number of other concerns like secrets as such. In other words, Dapr really can help on portability of an application, but it's not perfect yet. Okay, it's not perfect because, number one, the obvious thing, if I introduce a proxy between you and the cloud, what do? I introduce another layer that can cause problems. Dapr has a number of design principles in place that try to prevent issues, but they're still there. Dapr wants to be as transparent as possible. This is not always the case. And Dapper says developers should not worry about this. But it's not perfect. And the other issue is that if you offload a set of concerns onto configuration, you lose flexibility. For example, if your application wants to do something clever, so it wants to subscribe to a queue or a different queue during the life cycle of the application, you want to send a message to a different queue, you cannot do that with Dapper because now the configuration of the queue is in the config that is static, so you lose flexibility there. But it's a valuable feature nonetheless. Now, there's another service, by the way, similar to Dapper called Leotto out there. It's another CNCF project, but Dapper, I think, is way more mature. Let's now go into Dapper and think about another concern about all of this game. I put a proxy in front of a building block. Second issue, or second point of discussion is secrets management. So we said in our app, we were using Vault. We want to move to Google Secrets Manager. Library change, once again, not a major deal because usually Secrets Manager is not messaging. So the application reads secret at the beginning of when the application spins up and then doesn't do anything else. Typically, what we would do with Dapper, once again, Dapper introduces as a proxy layer, talks to Vault for us, and then when I swap Secrets Manager, I don't have to change the application. I just tell Dapper, go to Secrets Manager. There's a tricky thing, though, in doing this, which is, I think, is the most significant limitation with Dapper and similar services, which is that Secret Manager and Vault are not exactly the same service. Okay, they don't offer exactly the same feature set. In particular, Vault offers an interesting feature. Vault allows you to store secrets with multiple key value pairs per secret. So you have a secret that is effectively a JSON with multiple key value pairs. Google Secret Manager doesn't do this. Google Secret Manager is one key, one value, that's it. What does Dapper do at that point? Because the feature set is not compatible. So what do? Well, Dapper ends up going to the lowest common denominator. Because if you have a set, and this is a common problem across the services, so Dapper unfortunately has to be compatible with a number of building blocks. If Google PubSub offers more features than SNS, Dapper cannot offer you those features because it doesn't know where you are. So, to be fair to Dapper, they implemented multiple key values for secret in November 2022, so that specific problem is not a problem anymore, but there are a similar set of concerns. So, Dapper by nature ends up taking you to the lowest common denominator problem. Okay. Let's continue our migration journey. We've looked at a number of things. It's time for us to see how things are going. Okay, so number one, our microservices are up. Our systems are up. Now we can read messages. We can send messages. We can read from secrets. We can do a number of things. So why is our infrastructure SRE team shouting? Why are they screaming at us? Ideas?
Time to complexity for the monitoring.
There's a problem with monitoring. Yes, we'll look at that in a moment. Other ideas?
Access to the platform?
Yes, very close. Access to the platform, somebody said. Very close. Now, little hint here. We have Terraform in a garbage can. That says something. So, we are a migration team. We are Kubernetes experts. We're YAML folks. We don't really know Kubernetes. So we don't really know Terraform. We don't really know anything infrastructure management. We haven't really used anything. We did some ClickOps. We went to the management console and we deployed Cloud SQL manually. That's a disaster. Our infra team says, you're a bunch of fools. You don't know what you're doing. But we want to stay within Kubernetes. So what can we do? We could be using a new service called Crossplane. Now, Crossplane is a CNCF service, once again, that defines itself as a service, and I read here, is a cloud-native control plane framework that helps you building control planes without needing to write code. Now, what does it mean? I'm not sure. But it actually is very easy. So, Crossplane helps you unify the deployment of a Kube application and external cloud resources. It means if you have to deploy a cloud SQL, if you have to deploy a Postgres database outside of your cluster, RDS database, or a Cloud SQL database, you could be declaring in YAML to your Kubernetes cluster, I need the database, give me a Cloud SQL database. So this helps you keeping everything together, because now in your configuration of the application, in your deployment YAMLs of the application, you also have infrastructure code. How does it work? Very simple notion of a managed resource. Managed resource in Crossplane, we are seeing here a super simple bucket. I can create this YAML, deploy the YAML, a kube control apply the YAML on the Kubernetes cluster. Crossplane deployed inside the cluster, reads the custom resource and says, fine, I'm going to give you a bucket. Not only I'm going to give you a bucket, I'm going to keep you state consistency. So that if I change the bucket name in the YAML definition, Crossplane will go and change the name of the bucket, if possible, on the cloud provider. So this is very powerful and helps us deploying and keeping configuration together, both the configuration of the app as well as the configuration of the resources external to the app. But that doesn't really change much with Terraform, so we need to look at something else. We need to look at a notion of composite resources in Crossplane. So now, composite resources is an extra layer of abstraction. I don't declare I want a Cloud SQL database. What I do, I declare I want a Postgres instance. I call it X Postgres SQL instance or whatever I want, and I just say I need a Postgres instance. Then, with the notion of this composite resources, I can implement what I want behind the scenes. So I can implement the X Postgres instance as a Cloud SQL, as an RDS database. How does it work? Super simple. Our development teams goes there and creates a claim for a Postgres instance. The infrastructure teams configures Crossplane and tells Crossplane, you're in a Kubernetes cluster in GKE. When they require a database instance, deploy that as a Cloud SQL database and give them the variables back. So the application team doesn't need to know about any cloud provider. The application team can say, give me a Postgres database, happy times. And then the infrastructure team says, okay, good stuff. I can deploy that as a bucket. I can deploy that as a S3 bucket or a Google Cloud Storage bucket. The good thing about Crossplane is that Crossplane has a number of features as well, so namespace security. There are a few nuances there as well. We kind of like overlooked that in this super simple migration journey. But it's a very powerful thing, and once again, enables portability, because an application team just creates just creates a demand for a database. Okay. We're continuing our migration journey. We looked at infra deployment. We looked at, we swapped messaging systems. We swapped secrets management tool. Now, will it work now? Will it work? All our applications are up and running. Will it work? Yes, this time it does work. Okay, it works because when we did monitoring, we were much more clever than other things. This is 2022, 2023. Okay, this is not 2010, 2015. Monitoring in a cloud provider can be done in a variety of ways. When we configure monitoring on our AWS cluster, we selected the standard Prometheus and Grafana. AWS manages the services for us. But migrating now is much easier. I can export my Grafana dashboards, import them in Grafana on GCP, manage Grafana on GCP, and that is trivial. I can change some labels maybe, but it's very trivial. The dashboards are still up. It won't be the same thing. It would not have been the same thing exporting CloudWatch dashboards and importing them on Google Cloud Monitor. You see, depending on the service that we deploy on the cloud, on cloud providers, we can be more or less flexible about this. So monitoring was less of a concern, was easy enough. Overall, we've seen that our migration journey was helped by a number of CNCF tools. We have to be clever about this, but we can see here that with Dapper, with Secret Manager as well, with a number of these services, with the right monitoring tools, our portability was much more increased with crossplane as well. So what are the takeaways for this session, for this talk? So, as I said at the beginning, I often see the adoption of Kubernetes platforms in companies as a way to avoid vendor lock-in, to increase the freedom of choice of CSPs. They do this because they assume that in the context of Kubernetes, a pod deployment definition is bound to run on any clusters. We've realized that is not true because Kubernetes is not enough. We have to go to external services. We realize that the devil's in the details. We never just run one containers, we run multiple containers, and the interaction between those containers are the real problems. In other words, Kubernetes as a platform is not feature complete. We have to go to cloud providers or pay a significant cost. There's a significant cost to make it portable. We can stem that cost by using some CNCF tools, but if we really want to get portable, then we have to pay significant maintenance cost. All of this fragmentation of the ecosystem, all of this Kubernetes-wide ecosystem doesn't really help because we're not there yet. We need to be clever with all of this dependency on cloud providers. So cloud portability is hard work, and we've seen it. We've seen that an easy technical migration of super simple 3 microservices to cloud dependencies explodes in complexity. Cloud portability is hard work. The ecosystem plays a major role. The trend to make things more portable through with Dapper, but not only, through with even the S3-like managed services, is to move from the code into cloud infra components from code into configuration, from the SDK of the code into a piece of configuration that I can swap behind the scenes. And I hope you remember that. Open source can help, CNCF projects can help, but true portability comes at a significant cost. So, thank you. I think we have a few minutes for some questions, if there's any questions from the crowd. I'm sorry, I can hear you.
You sure that it would be difficult to have a multi-cloud strategy? Is there a situation where you would advise to have
Yeah, so the question is, if it's difficult to have a particular strategy, or there are situations where you advise one strategy or the other. And so, yeah, definitely I would advise choosing to be more portable at the beginning of a project if you know that you're likely to migrate across cloud providers, but telling your company that comes a significant cost with it, for sure. The other situation you have, which is very common across large enterprises, is that you're heavily regulated. So if you know that the regulator will tell you, you cannot use AWS for this project, and we've seen that happening in a number of European countries, then, especially in the banking sector, that in that case, if you have strong regulations that will force one way or the other, then definitely think about portability first. Okay, any other questions? Go ahead.
Did you consider moving your container registry into your infrastructure? So, for example, using GitHub as a container registry and not using something upstream to avoid that problem?
Yeah, so the question is if I consider using something like GitHub as a container registry or an external container registry. You can definitely do that. That is definitely an option. But in this sense, you lose something. What you lose is that in most cloud providers, pulling and pushing images from the container registry deployed within the cloud provider is, yes, more simple, but also, and the subtlety, is that if you have organizational policies that tell you you have to follow a certain set of rules, by staying within the cloud provider, I can adopt those organizational policies. The example is GCP. Binary authorization that we saw that says if you have to implement supply chain constraints, if you want to be SALSA, I'm not sure if you know about SALSA framework for supply chain, you want to be compatible with that, then you have to use binary authorization. If I leave Google Container Registry and I use GitHub, I'm more portable, yes, but I lose the stack control on supply chain security in that sense. Okay, yeah.
Can this migration be done without service outage?
Oh,
How long does it take like, to migrate this state? For example, the database.
Yeah, good point. So the question is, can this migration be done without a service outage? The answer is that we simplified the migration. We wanted to make it simple by definition. So I said, whatever, we don't need to worry about uptime. We would have a maintenance window. It is way more interesting. I think it'd be also the evolution of this talk in the future is what if we're actually multi-cloud? What if we actually are running an application across different cloud providers? We want to move workloads from one to the other without downtime. How do I manage the network flows? That is definitely more of a tricky thing. In our case, we didn't worry about it, but could be an interesting follow-up to this session. Any more questions? Any more? All good, perfect. Folks, thank you very much for coming. If you have any other questions, reach out. I'm available.